Now let's go ahead and look at some examples of how to calculate the measures of spread. So there are a couple different measures of spread. We're going to specifically look today at the range, the standard deviation, and the variance. So let's go ahead and start out with range. So the range is the simplest measure of spread. It's basically just the maximum value minus the minimum value. So if we look at puzzle number 1, we have a list of numbers 1, 2, 3, 4, 5, and 6. And the range is just going to be the maximum value, which is 6, minus the minimum value, which is 0. So the range of this list of numbers is 6. Pretty straightforward. And Wade, is there a way to find the range in Python?
So Python doesn't really have a built-in range because range is sort of a compound number, and it's not something you use a lot in data science. So I have never found range in Python, and I don't think there's an easy way. You can find the max number by doing .max, and the min number by doing .min. So if you were to ask me to find the range, I would say df.max minus df.min.
Perfect. That is good to know. So Python doesn't have, like we talked about with measures of center, Python does have a .mean and a .median, but it doesn't have a .range, but we can use the maximum and a minimum value to find the range of any column in Python. So range is pretty simple. Let's talk about standard deviation, because I actually think that standard deviation is more commonly used in statistics than range. What about computer science?
Standard deviation is really critical for all of data science and computer science. And it really is a measure of how far apart things are. It's a classic measure of spread.
Yes, exactly. And so the standard deviation, which you'll sometimes hear us refer to as the SD, measures the spread around the average. So in other words, a low standard deviation means that the numbers are really close to the average. A high standard deviation means that the numbers are more spread out. And if I was going to write the standard deviation in symbols, do you use a specific symbol for standard deviation?
Yeah, it's a lowercase sigma.
Yes, a lowercase sigma. And just like with mean and median, this actually represents, in statistics, this is the population standard deviation. So again, it's common to distinguish between a population and a sample. And then for a sample standard deviation, we actually just use a lowercase letter s to represent this sample standard deviation. So the thing about standard deviation is that if we're looking at a population versus a sample standard deviation, there's actually a different formula, which isn't the case for mean and median. So Wade, do you know if Python specifies the population standard deviation or sample standard deviation?
So in data science, we're almost always looking at samples. So by default, Python and almost every other programming language specifies a sample standard deviation.
All right, so Python gives the sample SD. And that is definitely good to know, and that makes sense. I can't think of a time where we would need to use the population standard deviation, or that we would even have the population standard deviation instead of the sample. And so whenever we do calculations with standard deviations, we're going to use that sample formula, which we'll get into in a minute. I do also want to mention our third measure of spread right now, which is variance, because the variance is basically the standard deviation squared. And so for our symbols, we can use sigma squared to represent the population variance. And then we can use the little s squared to represent the sample variance. And I personally don't like to use variance as much just because I think it's difficult to interpret because of the squared, but it does come up later in statistics, especially when we end up talking about inference and expected value, which are two other topics that will come up in this series. Do you use variance a lot, Wade?
I rarely ever use variance. I'll see it a lot just because it's a kind of a nice word and it really describes what it means. But honestly, standard deviation is what I always reach for.
Exactly. So I already put the symbols up here. So I'm actually going to write out the formulas for standard deviation and variance so we know how to calculate them. So I'll just do standard deviation, and then to get the variance, we're just going to square that. So to find the standard deviation, we can either write the formula in symbols or we can write it in words. So I'm going to write it in symbols first, and then I'll go ahead and explain what it means in words. So to find the sample standard deviation, which we denote as S, we're basically going to take all of the numbers on the list and subtract the average. So to write this, I'm actually going to write X to represent a number on the list. You could call it whatever you want. I'm going to call it X. And I'm going to say we're going to subtract X bar, which is the average. And then we want to actually add all of them together. So take the sum. So a lot of times in data science and in math, you'll see the sum represented as the capital letter sigma. So that's what this is. And then I am going to actually square all of these differences and then divide by n minus 1. So this formula looks kind of scary, but it's actually not that difficult to find. And in Python, we have commands that can find that for us. But this is what's going on behind the scenes. I'm not super concerned that you memorize this formula, but this is exactly what's going on with Python when we calculate it. So I'm going to go ahead and find the standard deviation and variance by hand with an example, and then Wade is going to double check in Python that that's what we get. So again, to find the variance, we're just going to take the standard deviation and square it. So once you find one, you basically have the other. So I'm going to break down this formula in terms of words and in terms of steps. You may like that better. So to find the SD invariance of this list of numbers, the first step, we want to know what is every single number on the list minus the average. So how far is it from the average? So step one is to actually find the average. So the average of this list of numbers, and our list of numbers, again, is just 1, 2, 3, 4, 5, and 6. So wait, what do we get as the average?
So the average of 1 through 6 is going to be 3.5.
That looks good. Including a 0.
Oh, including a 0.
Including
Sorry,
a 0. Actually,
0.
I said that looks good, but it's actually, I think the average should be 3.
The average with the 0 included is 3. I missed the 0. I'm so sorry.
No worries. So hopefully this makes sense. To find the standard deviation, which is how far are all the numbers from the average, we need to find the average. The second step is to take every number and subtract the average. And these are called the deviations. So I'm actually going to say we are going to find the deviations, which are really just every number on the list minus the average. So I'm going to take all my numbers and subtract 3. So my deviations in this case, I have 0 minus 3, which is negative 3, 1 minus 3, which is negative 2, and so on. I get negative 1, 0, 1, 2, and 3. And you'll notice, what if these deviations sum to, Wade?
So those deviations will sum to 0 because all the negatives and positives cancel out.
Exactly. All the negatives and positives cancel out. And that's actually something that we're always going to see with deviations. So the deviations, I'm going to make a note here, always sum to 0. So you can kind of check yourself if you're doing this by hand to make sure that you did everything right. So now we have all these deviations. We know how far every single number is from the average. But if we take the average, if we just find the average of those deviations, we get 0. So the next thing we're actually going to do is square the deviations. So I'm going to basically look at all of these numbers and make them positive by squaring them. So negative 3 squared is 9, positive 9, negative 2 squared is positive 4, and so on. My other squared deviations are 1, 0, 1, 4, and 9. And then the next step is to go ahead and add these together and then divide by n minus 1. Because remember, we're always looking at the sample standard deviation, and that's what we divide by. So step 4 is to go ahead and add all these together. So I have 9 plus 4 plus 1 plus 0 plus 1 plus 4 plus 9. And that is 28. And then I'm going to divide by n minus 1. So n is our number of observations, which is 7, right?
That's right. 0 through 6, 7 numbers.
So we're going to divide by 6. So I have 28 divided by 6. Wade is using Python as a calculator.
And I get 4.66667, so 4.67.
4.67. So this is actually, so the last step is that I'm going to take the square root of that. And before I do that, I can go ahead and say that this is my variance. So if you get to step 4, that calculates your variance directly. And then the very last step, since we are in squared, our units are squared. We want to unsquare them basically so that we can get back to regular units, is to take the square root. So I'm going to take the square root of 4.67 to get our standard deviation. And what do I get?
I get 2.16.
So 2.16 is our sample standard deviation. So I don't know about you, but I didn't really like doing that by hand. It was too much.
It's a lot of work.
It's a lot of work. So luckily, Python does have two commands that we can easily find the standard deviation and variance. So Wade, what are those?
So for standard deviation, we are lazy as computer scientists, and we want to type as little as possible. So for standard deviation, we just call it .std.
Sounds good. So we can do df at whatever the column name is, .std, to get the sample standard deviation.
And similarly, we want to be lazy, and variance is .var.
And that is an easy way to calculate these statistics, but it is definitely important when you're using these commands in Python to know what's going on behind the scenes. So we have the formula, we know measures of spread, and now we can continue on with descriptive statistics.